Welcome to Celestial Whispers, where we unravel the mysteries of the cosmos. Today, we're journeying to a planet that's practically our next-door neighbor, yet still holds so many secrets. Mars. Picture the red planet, crimson plains, dusky skies. But did you know Mars has its own light shows? I am talking about auroras. Now, these aren't quite like the dazzling northern or southern lights we see on Earth. Martian auroras are far more subtle, more varied, and they're teaching us incredible things about Mars' thin atmosphere and its constant battle with the solar wind. And this isn't just for cosmic curiosity. Understanding these ghostly glows is vital as humanity gears up for future missions to Mars. So what makes Martian auroras so different? Unlike Earth, Mars doesn't have a global magnetic field acting as a giant shield. This one fact changes everything. Instead of concentrated light shows at the poles, Martian auroras can pop up in different forms and places, all thanks to lingering patches of magnetic fields in its crust, the solar wind, and what its upper atmosphere is made of. Scientists have found a whole spectrum of these Martian light shows. First, there are discrete auroras. These are the closest thing to Earth's, but fainter and usually seen in ultraviolet light. They appear near those patches of old magnetic fields, mostly in the southern hemisphere, acting like mini-magnets funneling solar particles. Then there are diffuse auroras. Imagine faint, widespread glows covering huge areas. These are usually sparked by major solar storms, when the sun throws a massive burst of energetic particles towards Mars. These particles hit Mars' atmosphere, causing it to glow faintly across the entire night sky. And here's a really unique one: proton auroras. These mostly happen on Mars' day side. Solar wind protons interact with hydrogen high up in Mars' atmosphere. The protons snatch electrons, become energized, and dive into the atmosphere, making it glow. Recent missions, like the UAE's HOPE orbiter, have shown these can be surprisingly patchy and dynamic, a real cosmic dance. HOPE also spotted sinuous discrete auroras. Imagine worm-like light ribbons stretching sometimes halfway across the planet. For years, we only studied these auroras from space, using orbiters. But then, something truly historic happened. In March 2024, NASA's Perseverance rover, right there on the Martian surface, captured the first ever images of a visible light aurora. During a big solar storm, Perseverance saw a faint green glow. That green is the same signature from excited oxygen atoms we see in Earth's auroras. This means future astronauts might actually see auroras on Mars with their own eyes, a soft green hue in the alien night. It was a fantastic team effort, with other orbiters confirming the solar activity at the same time. So, why all this fuss about faint lights? Studying Martian auroras is like getting a direct line to understanding the planet's atmosphere. They show us exactly how solar wind particles penetrate a planet without a global shield, which helps us understand how Mars lost much of its ancient, thicker atmosphere. The colors and altitudes of the auroras tell us about the atmospheric composition. That green glow confirmed oxygen. They reveal how energy from the sun is deposited into the atmosphere, affecting its temperature and circulation. Discrete auroras even help map out Mars' ancient, patchy magnetic fields. And crucially, watching how auroras react to solar storms helps us predict space weather impacts, vital for protecting future astronauts and our robotic explorers. Every new aurora sighting, every new type identified, helps us piece together the story of Mars, its past, its present, and how it interacts with the harshness of space. These ghostly lights are truly illuminating the secrets of the red planet. That's all for this episode of Celestial Whispers. Join us next time as we continue to explore the wonders of our universe.